All right, so let's look at an example here. Given the reciprocal squared function that is shifted right 3 units and down 4 units, which we saw previously, written as a rational function, then we need to find the x and y intercepts and the horizontal and vertical asymptotes. All right, so let's start with our function f of x equals, now remember it's the reciprocal squared, we went right 3 down 4, so that was going to be 1 over x minus 3 squared minus 4. All right, so what we need to do to get this to work, we need to have this as one whole rational function. So a numerator and a denominator, but no subtracting and things like that within two different basically rational expressions. So what we need to do is we need to get this to have a common denominator with this. Well, this is really right now 4 over 1 and 1 over x minus 3 squared. So we're going to have to multiply by x minus 3 squared over x minus 3 squared to get that to be the same denominators. All right, so simplifying that, we're going to have 1 minus, and then if we take x minus 3, squared, that's going to be x squared minus 6x plus 9. And so we're going to take a negative 4 times that. So that's going to be a negative 4 times that's going to be negative 4x squared, and then plus 24x, and then minus 36 all over. And now we still have our x minus 3 squared. Where did I get this? Cubed. Okay. All right. Now simplifying this, we have 1 minus 36, so that's going to be minus 35. So we have a minus 4x squared plus 24x minus 35 all over x minus 3 squared. Okay. All right, so I think that's where we need to start because now we've got some p of x over our q of x. Now q of x already is factored. P of x, that doesn't look factorable, so I'm going to say that we won't factor that anymore. We're just going to have to work with it as it is. Okay. All right, so what do we know? We know some vertical asymptotes from our denominator. If we set that equal to 0, we get x equals 3. So we're going to have, if we set x minus 3 equals 0, we get x equals 3. And so that's going to be our vertical asymptote. And what do we know about that? That's multiplicity of 2 because we have our 2 here. Okay, so that's a key. We have to know about that, multiplicity of 2. We can do horizontal asymptotes. So what we're doing is we're kind of going back to this. So to horizontal asymptotes, if they're equal, we're using just our AN over BN. And since we have x squared here, and this, if we square this out, it's going to be an x squared, then we'll just take our leading coefficients. And what are our leading coefficients? Well, really, this is a negative 4x squared plus 24x minus 35 over 1 times x minus 3 squared because there's a assumed 1. So if we say that, then we get y equals negative 4, and that's going to be our horizontal asymptote. Okay, so that will be our horizontal. So now we found the horizontal and vertical asymptotes. So now we need the x and y intercepts. Okay, well, let's do the y-intercept first. And what do? Well, we set x equal to 0 and we plug it in. Okay, well, we're going to plug it into this function here. So basically, we'll have f of 0 equals minus 4 times 0 squared plus 24 times 0 minus 35 all over 0 minus 3 squared. So that's gone, and then we just have a negative 35 over negative 3 squared is going to be 9. So it's going to give us the point 0, negative 35 over 9 is going to be our y-intercept. Okay. Now we need to find x-intercepts. And remember, to get those, if we remember, we set the numerator equal to 0. So then x-intercept is going to be cause the output to be 0. So that's only when we have the numerator equal to 0. So we set their numerator equal to 0. And so we get a negative 4x squared plus 24x minus 35 equals 0. Like I said, I don't think we can factor that, so I'm going to use a quadratic formula. So x equals a minus b, which is 24, plus or minus the square root of, and now we have b squared, so it's 24 squared minus 4 times a, which is a minus 4, times c, which is a negative 35, all over 2 times negative 4. Okay. Now, if I plug all that into my calculator, I'm going to have still a negative 24, and then the denominator is going to be a negative 8. And so this is the part I'm going to work with now. So 24 squared, and then it's going to be minus 4 times 35. And so that's going to be plus or minus the square root of 16 after you do everything in here. Well, square root of 16 is 4, so this is just x equals minus 24 plus or minus 4 over negative 8. Now I don't have enough room here, so I'm going to go to the next page. And so let's write that down again. So x is going to be a negative 24 plus or minus 4 over negative 8. So that gives us minus 24 plus 4 over negative 8, which is going to be minus 20 over negative 8, which is going to be a positive, and 20 divided by 8 is going to be 2.5. And then we also are going to get a negative 24 minus 4 over minus 8. So that's going to give us negative 28 over negative 8. So it's going to be a positive again. And that's going to give us a 3.5. And so our x-intercepts are going to be, and we'll have a 2.5 comma 0, and we'll have a 3.5 comma 0. Now we could leave these as fractions if we wanted to also, but I just went ahead and left them as the decimal form there. Okay, so do we have everything we need? The x and y intercepts, well, here's our y-intercept. We have the two x-intercepts. Horizontal and vertical asymptotes. Well, here's our vertical, here's our horizontal. And so we have everything we need based on the problem given and what we're asked to get. So that should be everything we need to do for our problem here. All right, so let's go on here. Now, if we're given a rational function, we can sketch the graph. So we're going to evaluate the function at x equals 0 to find our y-intercept. We're going to factor our numerator and denominator. And then for factors in the numerator that are not common to the denominator, we're going to determine where each factor of the numerator is 0, and we're going to get our x-intercepts. Or if we have to, we can do the quadratic formula again and get our x-intercepts that way. We're going to find the multiplicities of the x-intercept to determine the behavior of the graph at those points. So, it could be, up, or it could be down, or depending on what it is. So that's going to be a key there. Multiplicity of 1, it's going to have something more like that. And multiplicity of 2 or evens are going to be something like that. So it's going to be like that, or it's going to be like that for 1, and this will be 2. Okay. Then where was I at? Oh, for factors in the denominator, note the multiplicities of zeros to determine local behavior. For the factors not common to the numerator, find the vertical asymptotes by setting those factors equal to 0 and solving. Okay, so we're going to need to know the multiplicities of the zeros to know how it's doing, because at our asymptotes, we're going to have different things happening. We could have something like this if it's an even, or we can have something like this if it's an odd. Okay. For factors in the denominator, common to factors in the numerator, we're going to find the removable discontinuities by setting them equal to 0 and solving. So we find those and get rid of the removable discontinuities. Then we're going to compare the degrees of the numerator and denominator to determine horizontal or slant asymptotes. And then we're going to sketch our graph. So we've got quite a bit to do to actually sketch a graph, but once we're done, we can get a rough estimate of how the graph is going to behave. So Let's start with this one and actually find all the characteristics, find all the things we need, and then sketch a graph. So this one's nice. They factored it for us already. So all we really have to do is think about what does each piece mean, okay? So here, this is multiplicity of 2. This is multiplicity of 1. This is multiplicity of 2 again, and this is multiplicity of 1. So those are going to be key things when we get to going. Now we have, if we set those equal to 0, those will give us our vertical asymptotes and also kind of give us our domain. So our domain, if we write that first, it's going to be all real numbers except, well, we can't have x equal 1 and we can't have x equals 3. Okay, so we can't have those two. All right. And so our vertical asymptotes come out from there too. Vertical asymptotes. And I can't spell today. All right, so let's see, can we cancel anything? Numerator, denominator. Nothing cancels, so our vertical asymptotes don't disappear. And so we're going to have a vertical asymptote at basically our x equals 1 and x equals 3. Okay, now this one has multiplicity of 2. This has multiplicity of 1. So remember, with multiplicity of 2, what happens is they're either both going to go like that or they're going to go like that around that vertical asymptote. And multiplicity of 1, you know, we'll have, you know, something probably like that. They're going to be opposites of each other. So one's going to go one way, one's going to go the other way. All right. So now let's see here. How about our degrees? Okay, well, this is an x squared. This is an x. That's going to be x cubed on the top. And this is x squared and x. So that's going to be x cubed on the bottom. And so this is a given 1. So y equals 1 over 2 is going to be our horizontal asymptote. Okay. So that's going to be given that because we have even powers or equal numerator, denominator. So we just take our leading coefficients and that's going to be our horizontal asymptote. So we've got a horizontal asymptote, vertical asymptote, our domain. Now we need some intercepts. So what are our y-intercepts first? Those are easy. We just set, x equals 0. So if we go 0 here, that's going to be 2 squared. So we'll get, let's see, is this f of 0? That's going to be equal 2 squared. And then times -2 over 2 times -1 squared times -3. So it's going to be 4 times 2, so it's going to be a -8. And this is going to be a positive 1. That's going to be a -3. So 3 times 2 is 6, so a -6. And reduce that, it's going to be plus. 2 goes into both of them, 4 over 3. Okay, so that's going to be our point here. So it's going to be a 0 4 thirds is going to be our y-intercept. And what are our x-intercepts? Okay, x-intercepts. We're set our numerator equal to 0. And so we'll have 0 equals x plus 2 squared times x minus 2. And so here that tells us x is going to be a -2, and here x is going to be a 2. This is going to be multiplicity of 2. This is going to be a multiplicity of 1. Okay, so that's going to be a key there. And so if we write that actually as points, we'll have a -2 comma 0, and we'll have a 2 comma 0. Okay. All right. So what else do we need to have? I think let's start drawing and see if we need anything else. All right. So there we have that. Now at y equals a half, we have a horizontal asymptote. So maybe let's make our asymptotes equal to that. So maybe if this is 1, 2, 3, -1, -2, -3, -1, 2, 3, 4, 1, 2, 3, 4. All right, so y equals a half. So somewhere like that, we have a horizontal asymptote. We've got vertical asymptotes at 1 and 3. Okay. 1, 3. Now let's find our intercepts. So let's plug our intercepts in at a different color. Maybe we can use black here this time. So 0, 4/3. So 0, 4/3, maybe about here. Okay. Then we have a negative 2, 0. And we have a 2, 0. And so we've got that, we've got that, we've got that. Those. All right, so I think we've got everything now. So now we can start drawing. Maybe we can use, I don't know, let's do green here. All right, so we know at the x equals 1, we have multiplicity of 2. So both of them have to go up or both of them have to come down. So this is multiplicity of 2. This one has multiplicity of 1. And so that's going to help us because now we're just going to be drawing these things in. Now, with our horizontal asymptote, what happens is we know it's going to come through or approach either way. And so since we have a point here and we point here, that means it's going to go through on this side. And what after that means is it's going to bounce up at some point and it's going to get close to there but never touch. And so, that means we're kind of probably going to come up here. And so since we're coming up here for this one, this has to come down. So let's draw, well, we actually have to hit the point though. Then it's going to come back up and get really close. It's never going to touch. It's just going to get really close. Now this one has to come down. And what do we know about, so this one is 2, and so that negative 2 here, that had a multiplicity of 2. So we know it's going to bounce off, okay? So with multiplicity of 2, it bounces off. Multiplicity of 1, it's going to go through. So 1 in multiplicity is going to go through the point. With even multiplicity, it's bouncing off. So that's something we had to remember from the last section. So that one, that's why it bounced off here. Now this one is going to go through. Now, since this is a 1 and it's going through here, what most likely is going to be the case is it's going to do something like that, okay? So we know it's going to do through here 1, it's going to go straight through roughly, and that'll be that. Now, we have one last piece out here. And so since this has got the odd multiplicity, this has to come down now because this went down here. This has to come down. And since we have that horizontal asymptote, it's just going to get really close to it, but never touch. And so it's going to look something like this as far as our graph of this here, okay? And again, if once you get this plotted and you want to make sure you have the right thing, you can always do a check with your calculator, but you need to be able to get all of these points, all this stuff, and then rough sketch it in and see and make sure you have everything and make it look like it's supposed to. And then after that, if you want to check, then you can check and see by plugging all that into your calculator. I'm not going to do that because that's just a matter of just plugging it in and seeing if it looks the same. But I think it should be the same based on everything here. So we have the multiplicity of 2, so we know it bounces off, it doesn't go through. Multiplicity of 1, it goes through. This has to come down from here, so that means because we're bounded here by the asymptotes, it has to come like that. And so those, I think that's everything we need to have for this one. So I didn't need this page, and we'll stop there and we'll come back with more.